Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The isoelectric point, pi, is the pH at which the amino acid carries no net charge, zwitterionic form predominates. At pH values below the pi, the amino acid is protonated, positively charged. At pH values above the pi, it is deprotonated, negatively charged. Moving on to the next step. Identify the pi. The pi of this amino acid is 6.0. Moving on to the next step. Compare the solution pH to the pi. The solution pH is 1.0, which is much lower, more acidic, than the pi of 6.0. And for the final step, determine the protonation state. At pH 1.0, the solution is highly acidic. Both ionizable groups, the alpha-amino group, typical pKa-9, and the alpha-carboxyl group, typical pKa-2, will be fully protonated. The amino group exists as NH3+, and the carboxyl group exists as CO2H, undissociated acid. Identify the predominant species. The fully protonated species has NH3+, positively charged amino group, and CO2H, neutral carboxylic acid, giving a net positive charge. This corresponds to option A H3N+, CH, R, CO2H. Eliminate other options. Option B H2N, CH, R, CO2H. This has a free amine, unprotonated, which would not be favored at low pH. Option C H3N+, CH, R, CO2. This is the zwitterion, predominates near pi is equal to 6.0, not at pH 1.0. Option D H2N, CH, R, CO2. This has both groups deprotonated, favored only at high pH. At pH 1.0, which is well below the pK of the carboxyl group, (2), and far below the pK of the amino group, (9), the predominant species is the fully protonated cation, H3N+, CH, R, CO2H. Therefore, the correct answer is A. Therefore, the correct answer is option A.